In triangle ABC, AC equals 12 centimeters, BC equals 15 centimeters, and angle B equals 15 degrees. Solve the triangle. Round answers to one decimal place. First, we'll draw triangle ABC. We know that side BC is equal to 15 centimeters, and point A lies on a ray from point B at an angle of 15 degrees to line segment BC. We also know that it is 12 centimeters from point C. Note, however, that there are two possibilities for point A. One corresponding to an acute angle A. This is given by this brown triangle. And one corresponding to an obtuse angle A. This corresponds to this purple triangle. When you're given two sides and one of the opposite angles, if the length of the side opposite the given angle is greater than the height, as shown in the diagram, note that the height in this case will be equal to the other side times sine of the angle, in this case 15 times sine 15 degrees, and it's got to be less than the other side given. In this case, the 12 is in fact smaller than 15, and it's bigger than 15 times sine 15 degrees. If this is the case, there will be two possible triangles for the given measures. This is called the ambiguous case for a triangle. We have to use the sine law to calculate the acute angle A, and then we will subtract this acute angle from 180 degrees to get the corresponding obtuse angle A. We then, for both measures of angle A, we determine angle C using subtraction of the other two angles from 180 degrees. And then we can find side AB, also called side C, using the sine law. Starting this out, we'll use the sine law to first calculate sine of A. Sine 15 degrees over 12, that's going to be sine of angle B over side B equals sine of angle A over side A. This results in sine A equals 15 times sine 15 degrees divided by 12. This corresponds to an angle A of 18.9 degrees. Note, of course, though, that we have another possibility. We can also take 180 degrees minus 18.9 degrees. This gives us another result for angle A of 161.1 degrees. We will first use angle A being 18.9 degrees and calculating angle C as 180 degrees minus 15 degrees minus 18.9 degrees. This gives angle C equals 146.1 degrees. We can then use the sine law again, this time to calculate side C. Sine angle B over side B is equal to sine of angle C over side C. This gives C equals 12 times sine 146.1 degrees divided by sine 15 degrees. This results in C equals 25.9 centimeters. We then have to do the exact same thing for the obtuse angle A, 161.1 degrees. Again, we subtract from 180 degrees 15 degrees, but this time 161.1 degrees. This gives angle C equals 3.9 degrees. Once again, we use the sine law. Sine 15 degrees over 12 equals sine angle C, 3.9 degrees, over side C. C then equals 12 times sine 3.9 degrees divided by sine 15 degrees, resulting in 3.2 centimeters. We then have two possible results. We have angle A equals 18.9 degrees, angle C equals 146.1 degrees, and side C equals 25.9 centimeters. We also have angle A equals 161.1 degrees, angle C equals 3.9 degrees, and side C equals 3.2 centimeters.